Hello students, as a continuation of the lesson electricity, now we are going to learn system of resistors. Resistors, combination of resistors is known as system of resistors. Combination of resistors is known as system of resistors. Resistors can be connected in various combination. Basically two methods, they are series and parallel. This is series connection of resistor, battery positive negative, resistor R1, R2, R3, ammeter positive negative, then key. Resistors are connected in N to N is known as series connection. Resistors are connected in N to N is known as series connection. இங்கு எடுத்துக்காட்டா பார்த்தீங்கன்னா ட்ரெயின் தமிழில் தொடர்வண்டி. இந்த ட்ரெயினில் பெட்டிகள் எவ்வாறு ஒன்றின் பின் ஒன்றாக இணைக்கப்பட்டிருக்கின்றதோ அதுபோல இந்த மின்தடைகள் தொடரணைப்பில் இணைக்கப்பட்டிருக்கின்றன. In series circuit, same current passes through each of them. Same current passes through each of them. Then series connection is a single loop connection. ஒரு சுற்று மட்டும் தான் அங்கே இருக்கு. Simple loop connection. If a loop is disconnected anywhere, the current will flow stop. The current flow will stop. If a loop is disconnected or broken anywhere, the current flow will stop. Example, serial lights for functions. If one is not glows, other all will not glow. To explain more, we all know that the flow of current happens only in the closed circuit. In the series connection, there is only one loop. Thus, if the loop is cut or broken, there will not happen the flow of current. Here, in series connection, current is common. In series connection, current is common, thus I, but voltage vary. So V1, V2, V3. In series connection, current is common, thus I, voltage vary, V1, V2, V3. Here resistance R1, R2, R3. Resistance are connected R1, R2, R3. According to Ohm's law, V is equal to IR. Thus, V1 I R1, V1 I R1, V2 I R2, V3 I R3. Thus, V1 is equal to IR1, V2 is equal to IR2, V3 is equal to IR3. Therefore, the equation V is equal to V1 plus V2 plus V3. Using this equation, V is equal to, what is V1? IR1 plus V2 IR2 plus V3 IR3. Since in series circuit current is constant, the three resistance R1, R2, R3 can be considered as one resistor Rs. In series connection, the three resistance R1, R2, R3 can be considered as one resistor Rs. Thus, V is equal to IRs. Thus, V is equal to IRs. We know V is equal to IR1 plus IR2 plus IR3. Here, combination of this equation, what is V? IRs. So, V is equal to IRs. IRs is equal to IR1 plus IR2 plus IR3. Here, we can take I is a common. IRs is equal to I is common. We can take outside I into R1 plus R2 plus R3. I, both side, I cancel. Then Rs is equal to R1 plus R2 plus R3. Rs is equal to R1 plus R2 plus R3. Thus, in the series connection, total resistance of the circuit is sum of each resistance are connected. Thus, in the series connection, total resistance Rs of the circuit is sum of each resistance R1, R2, R3 that are connected. Therefore, Rs is equal to NR. Here Rs is total resistance, NR is number of resistance. In series connection, total resistance Rs is higher than the individual resistance. In series connection, total resistance Rs is higher than the individual resistance. Next, let us see resistance in parallel. பக்க இணைப்பு. A parallel circuit has two or more loops through which current can pass. If the circuit is cut or broken or disconnected in one loop, current can pass through other loop. This parallel connection is used for house wiring. நம்ம வீடுகளில் பயன்படுத்தக்கூடிய wiring parallel resistance. Next, let us see, this is a parallel resistance circuit, battery positive negative, then voltmeter positive negative. Here point A to B, 3 loops are here. But in series connection there is only one loop. Here 3 loops, R1, R2, R3. Let us consider as R1, I1, R2, I2, R3, I3. In parallel circuit, the voltage is common. Here the voltage is common but current vary, I1, I2, I3. According to Ohm's law, I is equal to V by R. Therefore, I1 is equal to V by R1. Then I2 is equal to V by R2. Then I3 is equal to V by R3. The total current the circuit is given by I is equal to I1 plus I2 plus I3. Using these equations, I is equal to, what is I1? V by R1 plus I2 V by R2 plus I3 V by R3. Let the effective resistors of the parallel combination of resistors be Rp. Then I is equal to V by Rp. Therefore, what is I? V by Rp. So, V by Rp is equal to V by R1 plus V by R2 plus V by R3. We can take V as a common. V into 1 by Rp is equal to V into 1 by R1 plus 1 by R2 plus 1 by R3. We cancel. 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. When n resistors of equal resistances are in parallel equivalent resistance R by n. When n resistors of equal resistances are connected in parallel, equivalent resistance is R by n. Equivalent resistance is R by n. That is 1 by Rp is equal to 1 by R plus 1 by R plus 1 by R plus etc. 1 by R is equal to n by R. Hence 1 by Rp is equal to n by R. Hence Rp is equal to R by n. The equivalent resistance in parallel combination is less than the lowest of the individual resistances. Students, today we have learned series and parallel connection. Okay students, Stay at home. Take care. God bless you all.